Hi everyone, today we will discuss the greatest integer function, which is also termed as integral function. So this integral function, it is represented as a dot inside big bracket. So when we have a dot inside the big bracket, that means it is greatest integer function or an integral part function or simply integral function. Now this is in general, if you consider suppose f of x is equal to integral x, this way we write and this way we pronounce f of x is equal to integral of x. So here this x can be any number, it can be any real number, it can be integer, it can be fraction or any other quantities. So we have f of x equal to integral of x. Now the meaning of this is the greatest integer which is less than or equal to x. So we can have any value of this x, but when we consider the integral part of it, the greatest integer corresponding to that, it is an integer which is less than equal to x, the greatest integer which is less than equal to this x. So it will give you an integral value or an integer which is less than or equal to x. So if we take some example, so let us say integral of 2.9. So integral of 2.9, it will be equal to 2 because the greatest integer which is less than or equal to 2.9 is 2. So nearest to 2.9 we have an integer 2 or we have integer 3. Now out of these 2 and 3, we have to choose that integer which is less than or equal to this 2.9, means greatest integer, but it should be less than or equal to x. So 2.9, the integer which is less than this 2.9, it is 2. So we will take this as 2. Similarly, if you consider suppose integral of 3.7. So integral of 3.7, again the nearest integers are either 3 or 4, so we have to choose that integer which is less than equal to this 3.7, in general less than or equal to x, so that will be equal to 3. Similarly, if you consider suppose 4.8, integral of 4.8, so integral of 4.8, that will be equal to how much? 4. So that way we can divide. We can take some negative quantities also. Let us say integral of minus 5.6. So integral of minus of 5.6. So integers nearest to again the 5.6 minus 5.6 are minus 5 or minus 6. But we have to choose that integer which is less than or equal to 5.6, minus 5.6. So that will be equal to your minus of 6 because minus 6 is less than minus 5.6. This is a negative quantity, so you have to be cautious in that. So minus 5.6, the integer which is less than this, that is minus of 6. Don't get confused, it is minus of 5. So it is minus 6. So we will take that one. Similarly, minus of suppose 7.8, integral of minus of 7.8. So either minus 7 or minus 8. So what is the integer which is nearest to this and which is less than equal to minus of 7.8? So that will be equal to your minus of 8. So that way we can calculate the value whether it is in the positive side or in the negative side. Now you can see here whether the value is 1, value of x is 1, 1.1, 1.2, 1.5, 1.8, 1.999. The value of the integral function, it will be equal to what? 1. 1.1, anything. So nearest integer which is less than or equal to x. So that will be 1. It means in an interval between two consecutive integer, the value of the integral function that remains same. So let us see the value of this f of x equal to integral x when x lies between certain interval. So if you take x lying between 0 to 1, suppose f of x is equal to integral x and we are taking this x lying between 0 to 1. So what will be the value of that function f of x? So that will be 0 because f of x equal to 0 when x lies anywhere between 0 to 1. 0, 0.1, 0.2, 0.5, 0.999, approaching 1 but less than this 1. So throughout this interval, value of the function f of x, it will be equal to 0 if f of x is equal to integral x. Similarly, 1 to 2, anywhere lying between 1 to 2, so f of x, it will be 1. Minus 1 to 0, so minus 1 to 0, it will be what? Minus 1, because the integers nearest to this, in this interval, it will be what? Either 0 or minus 1, but we have to choose that integer which is less than or equal to x, so that is minus of 1. Similarly, minus 1 to minus 2, so you have this minus 2. If you consider, suppose minus 3 less than equal to x, x less than minus 2, you will get this as minus 3 and so on. So that way we can calculate the value of the function f of x equal to integral x when x lies between certain interval, and particularly between the two consecutive integers. One integer is included in this interval, the other integer is excluded in these intervals. That also you have to keep in mind. Now, if we, let us say, consider the graph of the function, suppose, because here we have different values in between two consecutive integers, but that value remains fixed as far as f of x equal to integral x is concerned, within an interval. Within this interval, f of x is fixed, and that is 0. Within this interval, it is 1. Everywhere it is 1. Within this interval, f of x is minus 1. So we can plot the graph of this function, and let us see how it behaves. So here, take x anywhere between 0 to 1. So 0, 0.1, 0.2, 0.3, 0.4 up to 0.99, something like that. So we are moving up to 1. We are moving to 1 but not equal to 1. So 0 to 1. So what is the value of f of x or y? F of x means y. So f of x remains same, and that is 0. So throughout this interval, f of x remains 0, means y remains 0, and that is equal to 0. So that all those points will be lying on the x-axis itself. So this is from 0 to 1, 0 to 1 but not equal to 1. Is this clear? So, but y is 0 when x varies from 0 to 1, excluding this one. Okay. Similarly, if you take this interval 1 to 2, so anywhere between 1 to 2, y is equal to what? 1. So at this point, y is 1. Here, this is your y1. So y is 1, again here it is also 1, here at this point of x, here it is 1, and so on. So for every point, y is 1. Similarly, if you consider this interval 2 to 3, so y is equal to how much? Y will be equal to, in this interval, 2 to 3. So if you consider 2 to 3, that 2 to 3 is not mentioned here. So if we consider that 2 less than equal to x and x less than 3, so this will be equal to how much? This is equal to 2. 2 to 3, f of x, it will be equal to 2. So you will get from 2 to 3, this is equal to 2. So y within this interval of x, y is always 2, because this is equal to your y is equal to 2. So the graph will be accordingly. Okay, so I think that is clear. Now similarly, you can take some point in the negative side. So negative side, 0 to minus 1. 0 to minus 1, x is lying between 0 to minus 1, y is equal to how much? Minus 1. Y or f of x, that is minus 1. So here it is minus 1. Is this clear? Because this is y is equal to minus 1, this part. So here at every point lying between 0 to 1, y is minus 1, minus 1, minus 1, and so on. Similarly, in the another interval, minus 1 to minus 2. So minus 1 to minus 2. Minus 1 to minus 2 in this interval, y is how much? Minus 2. So this is y is equal to minus 2, so you have this minus 2. Similarly, if you take other intervals as we have taken minus 2 to minus 3, so minus 2 to minus 3, y or f of x, that will be how much? Minus of 3. This is y is equal to minus 3 here. So we have this minus 3. So this way we can plot the graph of the function f of x equal to integral of x between different intervals. So this represents your graph. Now you can see here. So 0 to 1, 0 to 1 f of x or y, it is 0. 1 to 2, it is 1. 2 to 3, it is 2. Minus 0 to minus 1, it is minus 1. Minus 1 to minus 2, it is minus 2. Minus 2 to minus 3, it is minus 3, and so on. Now here we have considered, if you can see this, in this interval 0 is included, 1 is excluded. Now when you exclude any point from the domain of a function, so that point is numerically or symbolically it is excluded from that domain with this. Suppose if you have a domain of any function, x belongs to all real, but 2 is not part of the domain of that function, then how 2 is eliminated from that domain? So x belongs to all real except this 2. So this way we represent the domain of a function if 2 is not part of the domain. So x belongs to real except that 2. This I have considered arbitrarily for any function. So x belongs to all real except 2. So if you have to remove 2, so this is the symbol that we use. But graphically, when you represent the exclusion of any point on a graph paper, a bold dot is used to exclude any point on the graph paper. So here if you consider in this interval 1 is excluded, in this interval 2 is excluded, here 0 is excluded, here minus 1 is excluded. So we have to represent exclusion of all these points on the graph. So 0 to 1, just see here, 1 is excluded. So we have put this with the bold dot. Here if you see this yellow marking, so with the bold dot. Similarly 1 to 2, so this is the bold dot. 2 to 3, this is the bold. It means this point or this point, they are not part of the domain of the function. If we consider this interval, 0 is included in this interval. All other values from 0 to 1 it is also included, but 1 is excluded. Similarly in this interval 1 to 2, all values from 1 to 2 it is included, but 2 is excluded. So those point of exclusion, we are on this graph paper we have used this yellow dot here just to distinguish so that you can understand it properly. So with this yellow mark we have represented that. So exclusion of the point, it is considered with the bold dot. You can just put a bold dot wherever any point is excluded as far as the graphical representation is concerned, and simply we use this small curve as far as the numerical or symbolic representation is concerned for exclusion of a point. I hope it is clear. Now if you see, if you observe this graph, you will find different steps. Here this represents a step, this represents a step, and this is step. So can you identify? This seems to be the steps of a staircase. These are steps of a staircase. Just it looks like that these are the steps of a staircase. So when it is behaving as the steps of a staircase, so from that concept we say this greatest integral function or the greatest integer function, this is also termed as a step function. This is a step function. So you call it as greatest integer function, integral part function, simply integral function, or you call it as step function. This nomenclature is given just because of this geometrical representation, that it behaves like steps of a staircase. So we have this particular name, step function. Now if we see some of the properties of this, here you can see these are, you can say either the property or you can see how in different ways it can be represented, the integral function. If you have f of x equal to integral of x plus n, integral of x plus n, where n is an integer, this n is an integer, then it can be replaced or it can be represented as n plus integral of x. If n is an integer, you can take out of that bracket, that integral bracket or that symbol. So it becomes n plus integral of x. We have already observed many examples. I can again repeat that. So if you have, suppose x is equal to 2.5. So this you can write 2 plus 0.5. 2 is an integer, 0.5 is a fraction. So it means we can consider 2 plus integral of 5. An integral of 5, that will be equal to what? 0. 0 to 1 f of x equal to 0 when f of x equal to integral of x. So using that you can consider this. So either you can observe this and then you can elaborate and you get this, or just from the definition of the function f of x equal to integral of x, we have just observed that f of x equal to integral of 2.5, it means the integral value of that it will be simply 2. That we have already observed. So this is the significance as far as this representation is concerned. Similarly, if you see the second representation, x is equal to integral x plus fractional x, yani any number x, it is what? It is combination of integral part as well as the fractional part. So this just symbolizes, or we can rewrite like this. So x, any number, it is either an integer or combination of integer or fractional part. So similarly, if you see this 2.5 here, x is equal to, suppose your 2.5. So it is an integral part as well as what? The fractional part. Integral part here is how much? 2, and fractional part here it will be how much? 0.5. So this with the medium bracket, if you observe, this medium bracket, we use that medium bracket to represent the fractional quantity, this big bracket to represent the integral quantity or the integral part of that. So you can just see all these relations. So these are just the ways how this f of x equal to integral of x can be represented, or simply any number x, how it can be represented as part of an integer as well as fractional part. So it is nothing new, but just for your clarity we have mentioned, and sometimes when the situation gets complicated, you can just analyze this way and you can separate any number, either an integer or a fractional part of that. I hope this is clear. So we will make use of this integral function wherever necessary. It will be used in the calculating the domain of the function, it will be used in differentiation, it will be used in integration or any other part of mathematics. Thank you.